Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, let us try to understand the concept of time to live in Amazon DynamoDB, a very popular concept widely used by many companies in their backend architecture to implement complex use cases. Okay, how we can use this particular concept in building several architecture that I am going to cover in my upcoming videos. As of now, just let's focus on the fundamental concept and why we actually require this particular feature in DynamoDB. Let's try to explore that in detail. Okay. So suppose you are working on a time series data, and whenever we work on time series data, whether you are training machine learning model or whether you are using that data for data analytics, majorly our focus is always on the latest trends. Okay, that is current month what is happening, in the last month what happened, or max to max last to last month, like that. 5 years back what happened, that will not even bother, right? So based on that, here we can split our data in two major half. One is hot data, that is basically containing our latest data like current month's data or last month data, like that. And there is cold data. Cold data is containing the past data like last year what happened, last to last year what happened, like that. Okay, in the cold data, our machine learning model should not focus much. Rather than that, our machine learning model or data analytics team should focus on latest month or last month's pattern in the time series data, right? So here I hope you understood that there are several situations when we need to focus more on the latest trends rather than older things, right? So suppose all this data stored in your DynamoDB table. Now the older data, last year data, last to last year data, not even required by our application. So if there is any way to automatically delete that particular data or purge those data, maybe in S3 or in S3 Glacier, that would be great, because that way we can reduce the amount of data stored in our Amazon DynamoDB and we can save the cost of the storage also, right? So that's the beauty of TTL, because that basically helps us to implement this particular concept. That is, for every row, we can mention a timestamp after which the DynamoDB will automatically delete that particular row from our table. And that way, it will help us to reduce the DynamoDB storage volume. Okay, so that's what is written here. Amazon DynamoDB time to live allows you to define a per item timestamp to determine when an item is no longer needed. Okay, so per item basis or per row basis in our DynamoDB table, we have to mention that, see, this is the timestamp after which this row is no longer needed, and once the particular timestamp is over, DynamoDB in the backend will automatically delete that. We no need to delete that manually. Okay, so shortly after the date and the time of the specified timestamp, the DynamoDB deletes the item from your table without consuming any write throughput. Okay, that is, DynamoDB will take care of deleting that particular item. And TTL is provided at no extra cost as a means to reduce stored data volume by retaining only the items that remain current for your workload's needs. Okay, that's what I explained just now in the example also. That is, TTL is nothing but a way to purge the older data, okay, and keep our only current data in our DynamoDB table, and that way it basically control the total volume what is stored in our DynamoDB table. As simple as that. That's what is written here. Okay, so just to give you some idea what is the view of TTL. So this is basically one DynamoDB table. Here you can mention any particular attribute as TTL. Okay, like here the attribute name itself I have written as TTL, and the timestamp here we have to mention as Unix timestamp, that is number of seconds passed since 1st January 1970 12 AM UTC time. Okay, since then how much second passed, based on that we configure a time unit that is called Unix timestamp. That Unix timestamp here we need to mention. Okay, once the Unix timestamp is over, that is our current Unix timestamp, if it is greater than the mentioned timestamp for the TTL attribute for a particular row, that means that row is no longer needed. Okay, suppose our current timestamp is 16644600029. That means our TTL is having lower value than current Unix timestamp. So this particular row is no longer needed. Okay, immediately DynamoDB will not delete that. It is not happen real time, but eventually within 48 hours, DynamoDB will delete this particular row from our table, and that way the total volume in our table will be controlled, and obviously we no need to think about the old data. Dynamically DynamoDB will delete that. Okay, so here that's what I have written here. Expired items are removed from the table within 48 hours. It is not like immediately it will be deleted. That is one kind of drawback you can think. It is not a real time. Within 48 hours DynamoDB will delete. Okay, so suppose for a item TTL time is over, that is that item should be deleted, but still it is available in your DynamoDB table. So your application might by mistake consume that. So what you can do, if you want to enable TTL feature in your DynamoDB table, your application should be using filter option to exclude the items marked for deletion. That is, what items are marked for deletion? For which the TTL attribute is having lower value than the current Unix timestamp, right? For them, because those has to be deleted, DynamoDB will eventually delete that within 48 hours. But to make sure your application is not consuming that by mistake, you can apply a filter condition. Just like for example, suppose this is our DynamoDB table and here we are having TTL attribute. So whenever our application will consume, it can consume like this way. That is, just fetch those rows where TTL attribute is greater than current Unix timestamp. Okay, that way it will not consume those records which has to be deleted by DynamoDB within 48 hours. That is for which the time to leave time is over. Okay, right? That's what is written here. Application should use filter operation to exclude items marked for deletion. As simple as that. Okay. Now let's try to explore the TTL using lab experiment. So what we will do, we will build this kind of architecture what I already covered in my previous video also. Here we will be creating a DynamoDB table and we will basically insert some data in it, and then here we will create a Kinesis data stream and we will attach Kinesis data firehose also with it. Now as soon as for a particular row TTL is over and DynamoDB will automatically delete that, what will happen, the change data from DynamoDB stream, the Kinesis data stream will capture and it will dump in firehose. Firehose using Lambda, if you want you can do some transformation or else directly dump the data in S3. Okay, that is whatever data is deleted due to TTL over, that will be purged in our S3 for future reference. So our DynamoDB will contain only the hot data and our S3 will contain the cold data. As simple as that. So now let's start our experiment. So here if I show you my code, so in Google Colab, here I have written a very simple code which I explained in my previous video also, where we are reading a particular JSON file from Google Colab and we are writing in our DynamoDB table. So for that, here first let me install Boto3 because Boto3 is required to set up the connectivity with DynamoDB and our Google Colab Python platform. And then here what I am doing, here in TTL attribute, I need to provide the Unix timestamp. Okay, suppose once the row is entered, maybe after 5 minutes, the row should be deleted. So what we can do with current Unix timestamp, we can add 300 second more, and then that we can configure in our TTL attribute. So that way, after 5 minutes is over, DynamoDB will automatically delete that from the table. Okay, so how to get Unix timestamp? That is very simple in Python. Just time.time you can convert to integer. So if I just run that, here you will see we are getting the Unix timestamp value. Now here is the code what I am doing here. Importing Boto3, importing JSON, all this. Here I have taken access key and secret key just to create the Boto3 session for our DynamoDB. Here we are providing access key, secret key and the region also, which is US East 1 because there I am going to create my DynamoDB table. And then here I am creating the resource for our DynamoDB. And then here I am creating a table called TTL data. Okay, so I will go to my AWS management console and let me create the table simultaneously. So here create table name TTL data. Okay, now here what I will do, I want to make sure once the row is inserted, after 300 seconds or after 5 minutes, the row should be deleted. Okay, so what we will do in the TTL attribute, along with current timestamp, we will add 300 second more, and that we will put as TTL attribute for a particular row. Okay, so here I am reading a JSON file which is available in Google Colab itself. Here you can see anacombe.json. So that I am reading, which is containing the roll number, X and Y, these kind of columns or key value pair we can say in JSON data. And then here what I am doing, here I am adding one extra attribute, that is TTL equal to current epoch, unique epoch time or current Unix timestamp plus 300 second. Okay, here I have kept default TTL 300, so that one I am putting and that one I am entering in our DynamoDB. So each item, once it is inserted in DynamoDB, after 300 seconds, it should be deleted. Okay. So here roll number is basically we are using as primary key. So here I will put roll number as partition key, and that is basically number data type. And here what I will do, I will create this particular table, as simple as that. Okay, right? I hope up to this it is very simple. Here it is creating, let it create. So here it is active now. Okay, perfect. Now here what I will do, I will run this particular code. Okay, and here you can see that it is entering some data, total 0 to 43, that is total 44 records it has inserted. So if I go to my this particular TTL data, here you will see, if I go to explore table items, here the data is there. Okay, and here you can see the timestamp when the data should be deleted, that is also available. I can sort based on roll number. So for 0, the current TTL is this one. Okay, so here I can check whether this particular TTL attribute is lesser than our current Unix timestamp or not. So if I run this one, here currently it is false. Okay, that is TTL is not yet over. Once it becomes true, that means the data should be deleted from DynamoDB, and we have to configure the TTL attribute. That way the DynamoDB will automatically take care of the deletion. Okay, so for that what we will do, for this TTL attribute, we will go to basically tables, and then here this particular one, here I will enable TTL. Okay, what is the TTL attribute? For our case, the TTL attribute is TTL. Okay, so I will put that, and here I will enable TTL. So it will make sure for this particular table, the attribute for time to live is TTL. So once TTL is over, it will delete that particular item. Okay, now here as per architecture, what we need to do, automatically deletion happens, then it should go to Kinesis data stream from their Firehouse to from their S3. Okay, so here what I will do, I will go to Kinesis and I will quickly create a Kinesis data stream for our experiment. Okay, create data stream, provision. So here provision shard I am keeping one only, demo yt ttl 123. Okay, and then here I will create the data stream. Alright, and then here I will go to S3, and here I will create a S3 bucket also for our experiment. Create bucket, and here capture hold TTL data. Okay, and then here what I can do, here I can create the bucket, right? So here it is done. Now here I will first create a lambda function which will just add one new line character in our Kinesis data, like we did earlier also in the transformation. So here is the older code which I used, so that one only I will be copying and pasting, and all these codes I will be providing in the description box or in the comment section also. TTL new line adder. Okay, and then here I can choose Python 3.9, and here I can create the function. So here I can paste this particular code and deploy this one. Okay, in the configuration to avoid timeout, here I will make this as 5 minutes 3 seconds and save this one. And here in the permission section, I will make sure this lambda is having Kinesis access. So as of now I am giving full access, and then here what we will do, we will create a Kinesis Firehouse. Okay, as per the architecture, as you can see here, Firehouse will be added to lambda and Kinesis data stream. So here I will go to Kinesis, and here delivery stream, create delivery stream, and then here source is Kinesis data stream, destination is S3, and Kinesis data stream I will choose my data stream whatever I created. Okay, and then here transformation is required, and here lambda function I need, so just now whatever lambda I created, that one I'm choosing. Okay, and buffer is 1 MB, 60 seconds is fine, maybe I can put this as 3 MB, and here instead of 60 seconds I can put 120 seconds. Okay, destination S3 I will choose that one what I created just now as S3 location. Okay, so just now what I created is captured cold data, right? That is that one I will choose. So here capture old data, so I will choose that. Okay, and then here no need to change other properties. So here buffer interval 300 seconds is fine, buffer size 5 MB is fine, and then here backup is not required, advanced setting, other things are not required. I will here create the delivery stream. Okay, so here our delivery stream is created. Now all we need to do, the DynamoDB will automatically delete the rows for which TTL is over. So we need to enable this setup. That is from DynamoDB stream, it should go to Kinesis data stream. Okay, right. So for that I will go back to my DynamoDB, and here I will go to additional setting, export and stream, and then here I will enable Kinesis data stream. Okay, only one data stream we are having, we will enable this stream, right? So here it is enabling. So let's see whether our TTL is over or not for any single row. So here I will run just this particular cell to check. So here it is true. Okay, that means for first row, the TTL, whatever epoch time we have mentioned for expiry, that is over. So DynamoDB in the backend will automatically delete that. So obviously it is going to take some time. It is not happen real time. So let me just refresh. Here you can see time to live is enabled and DynamoDB stream is disabled, but here actually Kinesis data stream detail, it is now active. Okay, there is Amazon Kinesis data stream for DynamoDB capture item level changes in your table. Whenever change happens, then the changes will be pushed to the Kinesis data stream. From there it will go to Firehose. Okay, so let's see our table items. So if I refresh, so here you can see currently all the data is there. So we need to wait little bit. Within 48 hours all these rows will be deleted, and then we should get those same rows in our S3, that is this particular captured old data S3 bucket. Okay, so we need to wait little bit. I will start my video once all these rows from this DynamoDB get deleted. Okay,